Welcome back. This is Nick Egram. I'm going to discuss where functions meet. This is included in the quadratics because we're going to discuss two different functions. When you have lower mathematics, maybe when you studied lower mathematics, then you did systems of linear equations. It's almost the same. The process here is almost the same. For example, the questions that if you have g of x, for example, the red graph is a quadratic function, and the blue line is a linear function. So there are a lot of questions that you can ask here, and you can answer also. For example, in what coordinates when f of x is equal to g of x. Then we're talking about these 2 points. But if we're saying f of x is greater than g of x, that means the blue line is above the red line. Then we're talking about this area. That area. Okay? But when we're talking about f of x is less than g of x, that means the red line is above the blue line. Then we're talking about this area. And also this area. So I hope you will see the difference of the questions that they are asking. When we're talking about equal, then we're talking about just the coordinates. When we're talking about greater than or less than, then we're talking about a whole area. When we're talking about where the linear equation and the quadratic equation or quadratic function meets, then we're talking about 3 different possibilities: cutting 2 points of intersection, as we have here in our first figure. It can be just a tangent, one point of intersection, we call it tangent, and then missing. In your discriminant, then we have here, when we have our discriminant before, then b squared minus 4ac. When when you have two roots, then this one will be equal to greater than 0. When you have tangent, then it is equal to 0 if it's tangent, if it's only 1. If it's missing or there is no intersection at all, then we have less than 0. That is negative. So remember those things when we are solving functions where they meet. Okay? Here is an example. By the way, I am going to tell you again that all of my examples that I'm going to use in this series of videos come from this book, Mathematics for the International Students, by Robert H. et al. Okay? And let's see. Find the coordinates of the points of intersection of the graphs with equations y is equal to x squared minus x minus 18 and y is equal to x minus 3. without technology. That means we're not going to use a calculator. Let's see if we can do that. Sorry for the paper. Then point of intersection, then we have x squared minus x minus 18 is equal to x minus 3. If we subtract both sides of the equation by x and add by 3, by x, add by 3, this is 0, and that's also 0. Then we have the right hand side of the equation is 0. X squared minus 2x minus 15. If you want to test now, if you have two point of intersection or you don't, if you have one, then you can do the discriminant. B squared minus 4ac. B is negative 2 squared minus 4 times a, which is 1. C is negative 15. And we have 4 plus 60, and that is greater than 0. So we have 2 points that we're going to look at. There are two ways that you can do this, either by factoring or by completing the square at 3 ways. Factoring, completing the squares, or by the quadratic formula. I think the factoring is the easiest right now. For example, 15, we have 5 and 3. We need negative, so we have negative 5. So we have x minus 5, x minus x plus 3. Then we have negative 2. Negative 5 plus 3s is negative 2. 0. That means we have, x minus 5 is equal to 0. X is equal to, why is it 0? Is 5. And then we have x plus 3 is equal to 0. And x sub 2 is equal to negative 3. So we have 2 points. That is 5 and negative 3. Okay. Then we will solve for the y value. So when y is equal to x minus 3, so when x is equal to 5 minus 3, then y is equal to 2. You can use which of these functions. I use this because it's easier. It's simpler. We have negative 3 minus 3, then we have negative 6. So find the coordinates of the points of intersection of the graphs with equations. Then we have two functions there. As they said, we were not going to use technology. We already solved it, and then we were going to just look at it, control our answer by using the graphing calculator. I will show you my screen. Let's see. Here's my screen. I am using Casio FX9750G2. So if you have the same, then you can follow along. We have x squared minus x minus 18, and the other is x minus 3. Draw. I will just zoom for the window, exit window. I will type the initial. Zoom auto so that we can see. There you go. And then if we want to see the point of intersection, F5, and then we have the intersection, F5 again. That's 1, negative 3 and negative 6, we got it. And the other is 5 and 2, we got it also. Right, we got it right. Okay. This is another example. We'll do the same. Then we have x squared minus 4x plus 3 is equal to 2x minus 6. Then we have, if we subtract both sides of the equation by 2x and add by 6, minus 2x plus 6, then we have x squared minus 6x plus 9 is equal to 0. This is a perfect square. Then we have x minus 3 squared is equal to 0. When we have a perfect square, then we have only one root. We call it repeated root, which is 3. So it touches only one. It is called a tangent. So this is called the tangent line to x squared minus 4x plus 3. Let's see also with our calculator. Exit. We have x squared minus 4x plus 3. And then we have 2x minus 6. Draw. Then, as you can see, we have a tangent. And then if we want to see the point of intersection, F5 and then F5 again. Then we have 3 and 0. I didn't solve for the y. We can see y is equal to 2, x is 3, 2 times 3 minus 6. Then we have y is equal to 0. Another example is this one. We have x squared plus 4x minus 7. Let's see if we have point of intersection is equal to 5x minus 4. Subtracting both sides of the equation by 5x and adding by 4 minus 5x plus 4. Then we have x squared minus x minus 3 is equal to 0. If you want to take the determinants, we have b squared minus 4 AC there. But I guess I did something wrong here. We have negative x there. So we have negative x there. Substituting, we have negative 1 for b squared minus 4. A is negative 1 also. And c is negative 3. Then we will see that we have 1 minus 12, which is less than 0. That means we don't have no point of intersection. And then we will see with our calculator if that's true. We have exit there. Negative x squared plus 4x plus minus 7. And then we have 5x minus 4. Draw. As you can see, there is no point of intersection between the two functions that we have drawn. So like what I said from the start, there are 3 ways cutting. That means 2 points of intersection as our first example. Touching, or we call it tangent, 1 point of intersection, and missing, no point of intersection. Okay, in my next video, I will be giving more example, a little different example between 2 quadratic functions, and another is when we don't know the k, and some more examples. Okay, so see you around.